To VGuide TV. In this video, I am discussing the few questions from force and pressure. Few questions from force and pressure. See the question. In a container of cross-sectional area a homogeneous solid cylinder of length L, where L is lesser than h by 2 as shown in the figure, of cross-sectional area A by 5, is immersed such that it floats with its axis vertically at liquid surface with a length of L by 4 in the denser liquid as shown in the figure. The lower density is open to the lower liquid density is open to the atmosphere. Then the density D of the solid is. See, this is the question. This is a beaker. It is two liquid, one of density 2D, other one of density D. 2D at the down, D at top. And this is a block, okay? And the block of length is L. And we can see that L by 4 is lying in the down liquid and 3L by 4 in the top liquid. We know that if we keep the two liquids like that, denser liquid will go up and denser liquid, the less dense and high dense. Less dense will go up and high dense will go down. So D and 2D, 2D will go down, D will go up. So they gave it in the question L by 4 in the denser liquid. So out of these two, this is more denser. So L by 4 of this cube length is in the down liquid and the remaining 3L by 4 in the upper liquid. So this is a body. This red color what I showed is a body. This body L by 4 is in the down liquid and 3L by 4 in the top liquid. And total length of this body is L. Right? So I need to find the density of this block, density of the solid. Right? So how we can do this question? We can do this question by this formula. Weight of the solid body is equal to thrust exerted by the first liquid plus thrust exerted by the second liquid. Weight of the solid body, we know that mg. Weight of the body equation is mg. And both the first liquid and second liquid will exert an upthrust, and that upthrust is called buoyant force. And what is the equation for buoyant force is V rho G. V rho G, volume into density into gravity. Volume we can write area of cross section into length into density into gravity. So remember these two formulas. One is weight equals mg, other one is buoyant force formula V rho G. V rho G we can write in another form. Volume is area of cross section into length into density into G. That is your buoyant force. Now I am writing here in the diagram you have seen that there are two liquids, right? So I am just writing this as FB1 plus FB2. FB1 for the first liquid. So I can write here D is nothing but the density into how much portion. Now I'll show this diagram. D into how much length of the body is in the first liquid, 3L by 4. Area of cross section they gave it in the question as A by 5. So I can write here D into D is the density. D is the density. This is nothing but the length. This is area of cross section. This is your gravity. For the second liquid also, this is the density. 2D is the density. L by 4 is the length. A is the area of cross section is A by 5. And this is your gravity. So, AL rho G we are taking for both the liquids. Rho LAG plus rho LAG. Rho into L is 3L by 4 into A by 5 into G plus 2D into L by 4 into A by 5 into G. If you do this one, A by 5 is there in left side and right side. So, A by 5, A by 5, A by 5 cancel. G cancel. L cancel. So, remaining is D equals this part. 3 by 4 of D plus, here it will come as 2D by 4. 3 plus 2 is 5d by 4 is the answer. Very, very important question. Very important question. So see the question again. The question is a body we are immersing in a beaker containing two liquids of two different density 2d and d. And this body L by 4 part is lying in the down liquid and 3L by 4 in the upper liquid. So you remember we have a weight. For this body have a weight. Weight of the body should be equal to upthrust of both the fluid. Upthrust is called the buoyant force. Okay, when a body is lying in the fluid, there will be an upthrust. So upthrust is nothing but, you can write here the equation V rho G. V we can write A into L into rho into G. Now you see the diagram. Your first body, if you take the body in the first liquid, 3L by 4 is immersed and it is in a density D. Second one L by 4 and density is 2D. So your equation I am writing it as D 3L by 4 into A by 5, because A by 5 is the area of cross section of the body they are given. Area of cross section they are given. Now after that into G plus 2D into L by 4 into A by G into G. Then what I am doing? L A by 5 G. L into A by 5 G is common in all the terms. I cancel. Rest is D equals 3D by 4 plus 2D by 4, that equals 5D by 4. Clear? See the next question. A body when floats in water, 1/3 of its volume remains outside the water. When it floats in another liquid, 3 by 4 of the volume remains outside the liquid. Then the density of the liquid is. We can write here the way, according to our Archimedes principle, weight of the body is equal to weight of the water displaced. It means weight of the body, I told you, weight is equal to mg, mass into gravity. Mass we can write density into volume into g. So weight of the body is V rho G is equal to weight of the water displaced, means how much part is inside the liquid. So that's what V inside rho sigma. I used another letter, that's all. This is nothing but density only. Sigma W into G. Now see the question. They told 1/3 of it remains outside the water. So how much will be inside? V minus V by 3 will be inside. So V rho G equals V minus V by 3 sigma W G. What is V minus V by 3? 2V by 3 sigma W G. Sigma W, I told don't confuse. Sigma W is nothing but density of water. Density of water. So here also Vg get cancelled from both the side. We get a formula rho equals 2 by 3 sigma W. It means I got the density of body in terms of density of water. Now see the question they are telling. When it floats in another liquid, 3 by 4 of the volume remains outside the liquid. We are not taking the water, we are taking another liquid. So if you take another liquid, I am taking weight of the body is equal to weight of the water liquid displaced. Water we are changing to another liquid. So V rho G is equal to V in sigma Lg. V in 3 by 4 is outside me. How much will be inside? V minus 3 by 4 V into sigma L into G. What is V minus 3 by 4 V? V by 4 sigma Lg. So here also Vg get cancelled. So rho is equal to 1 by 4 sigma L. So I got two equations for rho. One is rho equals 2 by 3 sigma W in terms of water density. Another one is rho equal 1 by 4 sigma L in terms of another liquid. I am equating. So 2 by 3 sigma W equals 1 by 4 sigma L. Same term cancel. So sigma L equals no same term. So sigma L equals 8 by 3 sigma W. That is equal to 8 by 3 into sigma W. They gave it in the question. Or you have to remember here The water density is very, very important. The density of water is 1 gram per cc. Very important constant value. Density of water is 1 gram per cc. So 8 by 3 into 1 gram per cc, that is equal to 8 by 3 gram per cc. 8 by 3 gram per cc. That means second option, 8 by 3 gram per cc. So remember, the important formula, weight equal mg, that is equal to rho vg. Then sigma w is density of water. Remember, according to Archimedes principle, weight of the body should be equal to weight of the water displaced. Then the first question what I discussed, that's a very important question. If we immerse a body in two liquids, how we will write it? The main thing there also I told you, the buoyant force equation, don't forget, it will be equal to V sigma G, where sigma is nothing but the density of fluid. So buoyant force is nothing but the upthrust due to the fluid. Thank you for watching V-Guide TV. Please subscribe our channel and press bell button to get new videos. Thank you.